Hi, we have the AP Physics 1 past paper 2022. We are discussing free response question section. In this part, we have the question number 4 which carry the 7 points. In this, a student has a piece of clay and a rubber sphere, both of the same mass. Both objects thrown horizontally at the same speed at identical block at rest at the edge of identical table. Mean there is two table which are identical. There are two blocks which are identical. He throw the piece of clay and one case he throw a rubber sphere. With the horizontal, there is no vertical component. Both are have the same speed traveling to the block. Okay. As shown, friction between the block and the table is negligible. After the collision, both blocks fall the floor. Mean these blocks also fall and this block also fall. Okay. In case A, clay stick to the block A after the collision. In case B, rubber of sphere bounces off. Mean it after collision it return back after the collision. Okay. Now question is, in a figure at the left above, arrow represent the momentum immediately after the collision of clay block system in case A. This is the two block arrow is representing the momentum. Momentum is the product of M and V. In the figure, right dot arrow represent the momentum of the sphere block system. In this figure, we have to draw the sphere block system momentum immediately after the collision. If the momentum is zero, write the zero next to the dot. If the momentum is not zero, must represented by the arrow starting on and pointing away from the dot. Length of the vector, if not zero, should reflect the magnitude of momentum received to the case A. Okay, as compared to case A, we have to draw the momentum of the case B in which sphere and the block system is there. Okay, using the law of conservation of momentum, first consider the clay block system. Total momentum before the collision should be equal to total momentum after the collision. In system A, there is a clay, there is a block, and they stick together, so they are the combined now. So clay is moving, m and v is the mass of the velocity of the clay, that is the momentum. Because block is at the rest, there is no momentum. After that, they stick together, there is a combined mass mv. So what we see, the total mass and the total combined momentum still equal to the mv. Mean what we can say that the total momentum is mv. This is equal to this one. So of total momentum after the collision still equal to the initial momentum. So we can say we have to represent this is mv, total momentum after the collision. Immediately after the collision is equal to the mv. Okay. Now it is shared with the larger mass. The momentum is still equal to mv. Now, rubber sphere case plus block, total momentum should also be equal to after collision momentum. So there is a sphere block, there is a sphere plus block. Now, in the initial case, block is at the rest. So now the same argument is there. The total momentum after the collision still equal to the mv. Either we are not discussing individual values, we are discussing as a whole system, because it is asking the system, so still it is equal to the mv. So I have drawn the same vector as in case A as in case B. So if we discuss only individual, block must gain forward momentum to balance the backward momentum. Both have the momentum, but total momentum of the system still equal to the mv. So in this case, we draw the same vector as in case A, because in both cases, both are equal to mv. Okay. Now, what's the question? After the clay and the block collide, the block A lands the horizontal distance dA from the edge of the table. Does the block B land on a floor at the horizontal of the edge is greater than, less than, or equal to dA? In clear coherent paragraph length response that may contain equation drawing, explain your reasoning, neglect frictional effect. Okay. Now, answer is horizontal distance of the block B is greater than. So that's mean the block B will cover greater distance from in falling. But first of all, we have to discuss momentum of the clay block system and sphere block system before the collision is same for both cases. As we have discussed in this case, both is same, both is equal to mv. But and other point, the both block has no vertical velocity initially, say fall from the same height. So fall time of fall is same for both cases, as s is equal to, it can be represented by h of height, and initial velocity is zero in both cases vertically. So a is replaced by the g. So t is equal to 2h by g. H is same for both cases. G is same for both cases. So time of flight is same for both cases. Now, what is have to discuss? Now, let's say case A, clay stick to the block A, so collision is inelastic. Conservation of momentum gave the clay block speed. Mean you initially the clay has the momentum, but the block has zero momentum. After that, both are the combined mass. Now there is a this momentum still equal to the this. So we can say mass is greater, velocity is less from logically, because we have to this is the combined momentum of the system, that should be equal to mv. So to for the equivalence, there is now mass is greater as compared to this, so velocity should be less as compared to this. So logically we can arrive that this system has the less velocity as compared to the clay. Okay, now what happened in the case B? Rubber sphere bounced back, more forward momentum. Okay, so more forward momentum, block B compared to the case A, assuming the elastic collision simplicity, block B receives the bigger kick, it leaves the table with higher horizontal velocity. Now, how we can achieve reach this conclusion that this has the greater velocity? As a whole system, if we discuss, this momentum should be equal to the initial momentum. So if there is initial momentum, that is mv, after collision it is should be mv. So both are moving. After this is moving backward, this is moving forward. To bring the answer mv, this should get the more kick. As we replace here, there is a larger kick from the rubber sphere, or can we say there is a greater momentum, more forward momentum get block B. So with the higher velocity, horizontal velocity, block will same height of flight have, faster moving block will travel further horizontal distance because velocity is greater in this case and distance travel is more as before hitting the ground. As you get, there is a total momentum is should be equal to the initial momentum. So we have to come, both blocks are moving to get the answer. This should get more momentum. So I symbolically represent, and not necessarily that should be the same ratio, but 2mv is equal to forward momentum, and mv is backward momentum, net momentum is still mv. So that's the equation to get their block B get more momentum mean more velocity. So that's is the case, he will get more horizontal distance. So this is the answer. If you get any query, kindly ask in a comment. If you like the content, kindly subscribe and share it with your friends. Okay, take care.